Right, so another video on the Fehlmann. I've got some more of the electrics sorted out now, so that they're functioning, the 3 phases all connected up, and the various features of the elevating head is now in operation. So I'll show that working. So we've got 2 buttons that I've got temporarily rigged up. Again, this would be nice to have this set up in Mach 3. There are a set of stops on the other side of the machine, 3 stops. I think that the manual says they're supposed to be operated in the downward position only. I'll try and put a photograph of those in. It's very difficult to get any video footage of them, but I'll try and interpose a photograph in so that we can see those. So this is the head going down. The noise you could hear then is the hydraulic motor cutting in, which is putting the pressure up in the accumulator, which operates this device here, and that's interlocked to the relays which operate the head going up and down. So coming down, and then when I release this, you can probably just see this pipe here at the back here just moving. That's clamping the spindle, the head to the column, which is this tapered keyway that I mentioned in the other video. So going up, this thing has got enormous capacity. I can't take it all the way up because one, I think it starts hitting my some of my material I've got stored there. It's just lifting up. Also, the top of the motor cover is just hitting the top, but look at the massive space that you get underneath the spindle. Now, it must be getting all pretty. Your mechanical loop is getting pretty big at this sort of height. So I don't think I'd fancy doing any milling at that height, but certainly drilling would be okay. Light milling, I suppose, and then bring the thing all the way down to the bottom again. So as I say, there are stops on the way down which operate and should be interlocked with the relays. I haven't got any of that set up at the moment, but it's all quite a nice arrangement. Again, it would be nice to have this done in Mach 3, but not essential, because I think that the 120 millimeters or so of travel on the quill really gives enough of the Z-axis to be able to do most of the things I'm going to want to do. Most of the jobs I'm going to want to do are going to be 2.5D, so it's not really going to make that much difference to me. Okay, I'm going to run the spindle now. So I've got the spindle set so that it will operate in Mach 3, and it's coming from an inverter which is down here in the cabinet, and the spindle has got it's a 4-speed motor. So I'll just show that running now. I haven't got this terribly well set up in Mach 3, but nonetheless it is actually working. So there we are, running at its slowest speed, and that's the slowest motor speed. I'm not really sure what we got on the inverter. The inverter's only. Let's just increase this. So the inverter's running at around about 50 Hertz. So that should be giving the speed that's showing on the front here, which is around 700 RPM at the spindle. So that's the slowest motor speed. So I can stop that, and I can switch over to the next speed, which is, I think this should give us the next one on the chart here, which is 1250. Looks like 1250 to me. And off again. And now this next one should be 1640. So this is the next motor speed. Sounds about right. About 1400. I've not yet got to measure this, so I shouldn't have done that. That's switching the relay off rather than switching the inverter off. So that's and this now would be the fastest speed. Sounds like something's just tripped out there. No, don't think so. No, it's ready to go. Oh, reset. So that's all fine. The inverter's set up so that it does the braking okay. Well, what I really need it to do, instead of me switching these relays on and off here, I want the relays to be switched on and off by Mach 3. I've showed the electrical cabinet so that we can to show how I'm switching the relays, and well, that will become abundantly clear. So we'll go over to that now. This is the control cabinet, so all the usual stuff you'd expect to find. 3-phase in, 3-phase out inverter. It's a Darlin-Lander motor, I think I've mentioned before, which requires, it can't be run on 240 volts, so it's 3-phase in, 3-phase out. I'm lucky enough to have 3-phase here, so that's not a problem. Got my drivers here, driver power supply down here. 5-volt power supply there for the 2 breakout boards here. Then we've got this array of contactors along the middle there. They do all the motor control, and they control both the 4 speeds of the spindle motor, the up and down head motor, the coolant pump, and they also control one of those also controls the hydraulic accumulator motor, which has its own control circuit, which is pressure operated. All of the other contactors are in turn operated by the 8-module relay across the back there. So by switching on any of those, switching on the relays, they then switch on the contactors below. So if I do the lowest speed, that switches on the left-hand relay there, which operates the contactors below, and then that's the next speed, and the next speed, and the high speed. Now they can't. I've set up both lots of both contactors and the relays. The relays are all set up so they're daisy chained to each other on the output side. So it's, even if they're all switched on, they won't actually switch any of the control voltage, 24-volt control voltage, to the contactors. It will only switch the lowest, the first in the chain. So as we switch them on and off, it's the lowest one that comes in next. So it's always that first one if the next ones are all switched on. And if we switch off switch into last ones, it's always the lower one that's operating until the lower one is switched on. There's also a further protection as well, in that all of these contactors, the control voltages are all switching through the contactors again, so that if one speed is operated, then it's not possible to operate any of the other contactors. Each one is daisy chained through the other. The control voltage is daisy chained through the contractor control circuit itself. So it's absolutely impossible to get into a situation where, because this is a Darlander motor, it requires that the star point is made for the higher speeds. Now, the star point is also used to run the lower speeds, not when it's shorted, obviously. Obviously, if you had the shorted star point and put 3 phases across it, it'd be an enormous bang. So that's prevented. That cannot happen. It took me a long time to think about how to wire it, but that's how it's wired, and it's impossible to do it. So what I'd like to be able to do is to control that 8-module relay board there, which is all 5-volt operated. And these are very familiar things, very, very common. I'd like to be able to control all those relays from Mach 3. That would be really good. There are two. So 1, 2, 3, and 4 of the relays from the left-hand side on the 8-bank relay there, they control the motor, and then the next 2 relays along, they control the up and down movement of the head. So we've got up and down. And again, it would be really good to have those controlled through Mach 3, and also to have the limit switches, which I showed a photograph of earlier on. It would be nice to have those controlled as well. I think that covers everything. One last thing though that's really irritating about this breakout board, which has the motor control circuit on it, is that the contactor, the relay, is in a normally closed position when there is no power, which it seems completely crazy to me. I have no idea why it's doing it. So if the 3 phase is switched on, if the inverter is switched on without the computer being on, spindle runs, which is what it's doing now. It would be if I had the contactor on. There we go. So spindle's running. Now that's just completely and utterly mad. I'll reconnect here. Spindle stops. That's bonkers. I can't quite see how to wire it so that it's the opposite way round. So it has to have a high signal to close the relay, so that the relay's in the normally is when unpowered is in the normally open position. So somebody can point that out to me. I'll be very pleased to hear from them about that. Anyway, any suggestions on how I might deal with these with this relatively complex set of issues, I'd be really pleased to hear from people. Thanks for watching.